this student later. This is a superconductive crystal. We have a magnet also, small one, and strong. But I can produce superconductivity with a low temperature. Have you studied about superconductivity in physics class? At very low temperature, there is no resistance of the metals. Most of the metals which are conductors usually, and they have resistance, at the critical temperature, lower than critical temperature, they have no resistance. This is a sort of superconductivity. So this crystal has 92 Kelvin as critical temperature. It carries 92 Kelvin. 92 Kelvin is higher than the temperature of the minus 196 Celsius. So the liquid nitrogen has lower temperature than the critical. If we put the crystal into the liquid nitrogen, it has no resistance. And a very simple experiment, that's interesting. If you have a superconductor like this crystal, 92 Kelvin, the critical temperature. If it has lower temperature, no resistance. If you have a magnet, north, south, if you have a magnet, if you approach the magnet to the conductor, what happens with the crystal if the magnet approaches the crystal? The magnet can induce current in the crystal, induction. Have you heard about induction? If you push the magnet to a conductor, the magnet can induce current in the material. And the current in the crystal can flow forever if we have this temperature, because the crystal has no resistance. If you start the current in the crystal, it can flow as long as we have this low temperature, lower than the critical. And what's the other effect? If we have current, the current has magnetic field. It's covered by Ørsted, the Danish physicist. The current has magnetic field, and the magnetic field opposes the other magnet, which causes the induction process. So this is the Lenz law. So the current has an opposite magnetic field, and the magnet is levitating, is flying above the magnet. This is the effect. It shows that the crystal is superconductor. So if we have a small group, I can show it because it's a.
Is there anyone who knows where it is used, this kind of phenomenon is used?
At the end of this show, I can stay here.
Yeah, could you tell it to the others? No? It is used in Japan, for example, where several trains are moving on this kind of current, electric current, which is induced by the magnet, which is kept on a very low temperature, lower than 92 Kelvin, the critical temperature. And that's why the train is very fast, 500, 600 kilometers per hour, because no friction. Okay, so that's why it can move very quickly. Now in Japan and in China, they are building these kind of trains. It's quite expensive, but within several decades, it works the money back to the investors.
Okay. Or if you want to come closer, maybe two.
You have to. So please stand up and come
closer. Almost the last wait.
The last two rows stay there. Az utolsó két sor maradjon. Ők külön jönnek. The others should move front. Okay. Then you change. Okay. Wait. Sit down. Sorry.